Alright guys, welcome to another video, and in this video we will be learning function. In the last video we had so much fun. One key takeaway is how that we had a more challenging exercise compared to the ones we've done before. And why is that? It's simple. Now we've learned so much, so we are able to bring things together. Unlike when we started, when we just we only knew variables, we only knew data types, but now we know control flow, we know operators, we know variables, so we can now combine all of this together in a single flow and get things rolling, right? And get things rolling. So in today's video, we'll be focusing on functions, and functions will even help us do much more than we have ever done or that we have done before. So let's jump into it and see what it can do for us. What is function? Let's start from the very scratch. Functions are reusable block of code that perform a specific task. Quickly take your mind back to Excel or SQL or Power BI if you have any of those background knowledge, and you would have seen function used a lot of times. Let's say basic mathematical or statistical function or aggregate functions such as average, sum, count, and all of that. They are functions. Somehow there's been a code written behind the scene. Anytime we want to use them, we just type the function and then we can use it over and over and over and over again. Okay, so that is why they are reusable block of code that perform a specific task, one task. So they help us organize our code and make it more readable. Now, does that mean we cannot have more than one code in? Does that mean our function cannot handle more than one thing? Well, it can. It sure can. But by good practices and the rule of single responsibility, right? We're not supposed to, but it can work to work perfectly without any error. Okay, but it's good. It makes debugging easier if a single function is handling a single responsibility. We can easily know, oh, okay, this is probably what the issue is. But if a function is handling so many things, other things can spike from there. And the last thing is that, apart from the fact that it helps us organize our code, makes it more readable, it also helps us avoid repetition. And that is the dry principle that says do not repeat yourself. Don't repeat yourself. Okay, don't repeat yourself. And yes, now let's jump into it without further ado. We'll open this. How do we start with function in the first place? Very simple. We define function using the keyword def, def, def. Then we follow it by the function name. So this is the syntax, how to write it. Function name, that means whatever we want to call our function. Then a parenthesis, open and close bracket, and a colon. That's the way we do it. Then the body of the function is indented. And of course, by default, as long as we don't miss our colon, we get the automatic indentation. We've mentioned this over time that our IDs help us with the indentation part of things. So let's jump into it and write a simple function. So say def, let's just say greet user, then and just say colon. Now we can see immediately we put a colon, it's indented. Is not on the same level as def. However, if we don't have a colon, it goes to the same level as def. So make sure you don't miss out on the colon. And as we said, def keyword, function name, greet user, parenthesis, parenthesis, colon, colon. So what do we want the function to do? Print hello user. Hello user. Okay, that's not one exclamation. Now, unlike variable names, we don't call them, or we don't print them. We call them. So if greet user were to be a variable name or a variable, what would we have done? We would have just said print greet function, right? But for functions, we don't print them, we call them. And how do we call them? We just type its name followed by parentheses. That's all. So say greet user, open and close the brackets. That's all. So let's go back here and make sure we execute this first. Executed. Now we notice that we have a function called greet user, and then we can run this and then we get hello user. So this is how to call a function. It's as simple as that. It is as simple as that. Now that we have defined the function, let's collapse it and move on to the next thing. There is no time. So you can create another function to maybe say to undo a particular task or whatever it is. Of course, we'll still do that together. So I'll close the collapsing. I'll collapse the definition part. Let's look at the arguments and parameters. I think the order should be parameters and arguments. Parameters and arguments. Capital P. Parameters and arguments. So what are parameters? What are arguments? Parameters are simply variables inside a function. That's all. That's the simplest explanation, and that is what they are. They are variables inside a function. If they were outside a function, okay, let me be a little bit careful. Now, they are variables defined in the parentheses of a function. Yeah, let me be more specific. Okay, because we can have variables inside a function and they are still variable. Okay, so but they are defined inside the parentheses of a function. That means they go inside this place. They are called parameters. And what do variables do? They hold a value, right? So that means when we call them, because we pass something into the parentheses, we must also pass a value when we are calling them. So that value, or the value we pass when we call them, is what we call argument. Just like a sum function in Excel, type equals to sum, then we pass in what? Argument. Because upon creating that function, there has been an avenue created for accommodating values. Of course, how else would it be able to work on what we want to do? Because it's not a generic. We want it to be able to perform a particular task for us. So we want to be able to pass some values to it. It works on it and then returns an output. So to allow the input-output process, we must pass in parameters to our functions so that users can provide arguments, which is value that they want the function to work on for them. So let's jump into it so you see it more clearly. Now, we just define a function that can take an argument. Let's continue with our greet function. So say def, then we'll just say greet in this case. We'll say greet user, we don't want the other name. Then we'll say name. Okay. Now, what do we want this to do? We'll say print, and we'll say hello. Hello. And then we'll put name right here. And then we'll put full stop. Of course, we're missing our F formatted string. And now we get our formatted string. So we're saying this should print hello. And then they pass in their names. So if we run this, nothing happens. So let's call the function greet. Then if we run it, it's going to throw an error. Yeah, oops, it says missing one required positional argument. Just the same way we have it in Excel. You know, we have some functions that are what we have inside a function. We have optional arguments, we have required arguments. Okay, so we'll see the optional. We'll see how to make arguments optional. But in this case, he said we passed in a parameter, so it's expecting something. We must pass in something. So I can say Judith. Judith. And if I hit enter, then I see hello Judith. What if I say Clara? Clara, enter, and it says hello Clara. or if I say sustain, okay, and there we go. All right, so we can define a parameter with what? With multiple arguments. That means the argument does not have to be just one. But in this case, we have seen how to create argument with parameters. And busting in this case, or the value we're passing, is the argument. This is the parameter name, which is a variable that takes in the value we're passing, which is the argument we're passing. All right, let's see how we can use define a function with multiple arguments. So we can say def, we can say a function called add up, and you can say num1 and num2. So we can say print num1 plus num2. Okay, saying print num1 plus num2. And of course, we can call the function inside there. And then that will be add up. Add up. Open and close, we pass in 5, we pass in 3. Let's run that and see what we get. And you can see we're getting 8. It is doing that for us. However, if we look at our function, let's take this out. Now, if you look at our function, it's just saying function add up at. We don't understand what's going on. Remember our doc string. We can say this function adds up to given numbers. So adds up any two given numbers, any. Okay, so if we come back here now, we have to close this with triple quotes as well. So if we come back here to our function, we'll execute it again. Let's pass in 9 and 3. So we execute that, and if we come to our function, we can see it's now saying this function adds up any two given numbers, which is more descriptive. So we have been able to what? Add a documentation string inside our function. Now we know what it does, which makes more sense. All right. So we can define what? More than one function. Very soon we will consider the right way to print, or the right way to get value from a function, which is not print. So I think before we continue, it's good to take a look at that now before we look at this rest. I think I kind of pushed it down somewhere. Okay, so let's bring it up. Go up, go up, go up, go up. All right, so just right here, so that we can look at. Oh, and that's a lot in it. I hope I've not dragged something else. Yeah, I hope so. I hope not. All right, so you can create another function. So for you, create a function that subtracts or that takes the difference of two numbers, creates a function that returns only the remainder of two given numbers. So put all of those mathematical operators in use and get something out of them. Now you understand parameters on the basic level and you understand arguments. Of course, we'll look at how we can make things optional, because currently our arguments are they are required, so we can make them optional at some point when we please to, or when we choose to. And that's what we'll look at that after looking at the return values and the print statements. All right, so now this is a common confusion point for beginners. Actually, that's why I want to take time to clarify it. You see, there is difference between print and return. We've not seen return before. We've not used return in this video, in this code, in this particular session or lesson, but it is what we'll be using going forward. And I want to quickly clarify that before we move on any further. Now, what does print do? Print is only displaying our value, and it's just for human consumption. Okay, it's just to show that, oh, hello, this is it. Consider it like okay, now let me use that example. So it doesn't give you a reusable value. That means you can't reuse it. Whatever you print is printed, and that is the end. It's not saved anywhere. The value is not saved. It's destroyed after it's printed. Okay, in a function. All right. So it's just there, it's out there. So, however, for return can give you a value back. Return can give you a value back that you can use in other expression or calculation or operation. So let's look at a simple example before we now look at what we have here. Let's use our own example first. So we have this. So let's say we want to add a simple result. So let's say difference, def, then we want it to be number difference, num diff. So we have a and b as our variables. Then we say print a minus b. Okay, printing a minus b. Now in this case, we're saying outside there, we say difference should be equals to our function, right? So we're saying number difference, or let me just call it first, and then we try to save it into a variable before we see what we want to do. So let's do 4, 2, for example. Let's execute that. We're getting 2. Of course, there's no way I can use this 2 again, so let me save it in a variable. That's the point. Let's save it in a variable called difference. And we want to say, now that we've saved it in a difference, so we want to print out here the difference is difference. That means it's meant to print out the number saved in our variable, right? So just follow the logic, follow the flow. We're saying we have 2 functions, a minus b, and when user passing a value, we want to save the difference in this variable called difference, and want to print, oh, the difference is this. So let's execute this and see what it does for us. We've already passed in the value, but he's saying what the difference is none. Maybe I should change it. Maybe that's why we're not saying it. Let's say 7 and 2. At least it should print out first at this point. Okay. We're saying, oops, it's showing the difference. It's showing the calculation on that, but we cannot reuse it. It's saying the difference is none. Is none. So let's look at the other way of using return to get the same thing done. So Control C. So let's add P to this. P, that's for print. So no, this is for print. I'll just type print in full. Print, all right. So run this. Yes, perfect. And this will be return. Return. And then we'll say return. Okay, so we have return in this case. So we want to say, oh, return the total of this, and let's see how that works. So in this case, I'll run this again. This says none. Let's say this. Okay, I have to change this. So change this to return. So this is how we use the keyword. We just say return. You don't need to put it in brackets. We just say return a minus b. Put a space like that. And if I run it, you can see that it's not first printing the value. It's giving me perfectly, just as the difference is 5. So you can see how powerful the keyword return is when we are using it in a function. Why? Because the operation happened inside the function, so it is meant to stay there. But the way we get it out is to say, oh, return the result of the operation. I hope you have a good clarity on this now. Okay, so let's now look further into it. The examples I have here already. So you see, this prints the name. This prints the name. If we run this, we cannot reuse the value again, right? We can't reuse the name value. Because if we say um, print name, right, which is this particular value, we won't get it back. Okay, we won't get it back. However, if we use the return, if we use return, we can say, oh, start greeting, and then we can use the return value directly. We can use the return value what? Directly. So now in this case, I want you to carefully, that's why I gave this as an example. I want you to carefully review this code and make sure you understand it. Once you understand it, that means you can now think of what I thought or I just discussed, and then you can apply it on your own. So that is what I want you to do. So pay good attention to it. You can pause it when you're at this particular point. Come here as well, pause it, or you write it out, run it, and make sure you understand what is going on. All right. Now, one other thing is that look at this function. We have a function add, we have a function multiply. Now we can chain the functions using the return values. We can chain the function using what? The return value. How so? Add function, this is the add part. We're getting this addition result. And see the multiplication part. We're now using the result of the addition multiplied by 2. So let me run this. So we're printing final result. So let's print final results, and then we'll think about the result before we print it out. So if we pass in 5 plus 3, that will give us 8. Then 8 multiplied by 2, our final answer should be 16. And yes, that is absolutely correct. So pro tip for you: functions should generally return values if their purpose is to compute something that will be used anywhere else or elsewhere in our program. Use prints for debugging or for displaying final result to user. Print a function that returns a value is much more versatile and testable. So keep that in mind. That so going forward, we'll be using the keyword return. I hope with this you have a good clarity and distinction about the difference between the return value and the print keyword, the return and the print. Okay, why is this still here? Okay, on the argument and parameters. So after this, the return value. So something has jumped out of place. We have some keywords, argument, and all. Um, that probably jumped somewhere. So because after this, we are supposed to look at the keyword argument and the rest of the values. Okay, see where they are. Okay, I think this is on a bigger level. What level is this? 3. Okay, if this is level 3, so I think this is collapsing it inside. All right, let's change this to level 4. Just bringing it up is what made it go away. Now, where is it? Okay, now it has entered inside here, and yeah, we should be able to find it right here. Okay, so good. So this will be on level 5. Level 5, enter as well. This should be on level 5 as well. Enter. Okay. So return value. Good. So we have return value just like that inside our parameters and arguments. So it is meant to be outside on its own, by the way. So let's take it up. Return, jump up, jump out, jump out, and jump out. So yeah, let's jump in here. And we can now make it a bit bigger. I'll take it back to level 3. Good. So after we looked at definition function, we looked at return values versus print, and then we can continue with our arguments and parameters. All right. So we have seen this first argument. The next one we want to see is we want to see the positional argument. We want to see the positional argument. Now, arguments are passed to parameter in the order of definition. Okay, arguments are passed into parameter in the order of definition. Let's see something like that. So let's say name, def, user profile. So let's say user profile. So we get the name, we get the age, we get the gender. All right. So let's just say this, and we want to print user or name is age years old and is a gender. Of course, this will print the actual value. So let's assume we have values there already. We can say Jack is 5 years old and is a male. Okay, so this is what this is meant to do. Now, let's add this. Okay, we should have looked at this. I'll just push it up and push it up as well. Okay, I think it should also push up. Then push up again. All right, that's the flow that I want. So default arguments, positional arguments, where are they now? Okay, just a minute, let me just bring that back. Okay, so parameters and arguments, we've covered these. Default arguments, where is our cell? Our cell has jumped away. Our cell has jumped away. That's fine, we'll just create another one. Code. So define user profile. Even though it's still active wherever it is, name, age, user. So just quick one. Basic. Okay, good. Positional arguments, default arguments, keyword arguments, all the way like that. Age and gender. So what we decided to do is print or return. Now that we know, we say return, and it still works. Our f string still works. We just put f without the bracket, and we say name is age years old and is a gender. All right, so this is what we have. Escape B. So if we call it here, we can say user profile, user underscore profile, we can pass in we can pass in 30, the age, the gender will be male, and say the name will be ballistic. Okay, ballistic. Let's run this. We'll execute this first, and then we'll execute our function. And you can see what is returning. Now, it is returning 30 is male years old and is a ballistic. Now, this does not make sense, but what just happened to our code? Was it that there was a problem with our code? Well, not necessarily, but arguments are positional by default. Arguments are positional by default, so it is expecting it in this order. But because we supplied in the wrong order, it just applied it that way. So by default, it takes 30 and puts it inside name, male inside age, and gender inside ballistic inside gender. So let's correct this. So we'll say Josephine, then we'll say 45, then we'll say female. And of course, yes, we don't pass in numbers in string because they're actual numbers. So if we run this, we can now see Josephine is 45 years old and is a female. Of course, we can't tell if it's a she or a he or an he, though we can work with that in our function. Okay, we can do that in our function, that if it's this, then print this. If it's this, then print that as well. So if the gender is a he, then we want it to check print he. You can take that up as a challenge. It's easy to do. You just do it within this place, as an expression. Okay, as an expression here, so you can check if it's a male or a female. Then you print out she or he based on that particular condition. So it is important to know that arguments are what's positional. It is the order in which we write them. Okay, so keep that in mind. So quickly, let's jump back to our basic. We remember that when we try to run this function, our greet function, without an argument, it created an error. Let's try to run it again. It's telling us, hey. Okay, this time is wrong spelling. Let's correct that. Let's run that again. No, that's saying, oh, hey, missing one required positional argument name. So it was supposed to pass name. Why? Because it has been declared. So how can we make it optional such that if they provide it, we use what they provide? However, if they don't provide it, we just default back to, say, user or whatever it is we want to call them. And this will lead us to looking at default argument. Okay, default argument. I'll move that up. It's supposed to be just right after this. No, I think the order is correct. Arguments are positional. Then we'll look at default argument here. So in this case, how do we declare? Okay, we have some example. Okay, see the guy we were looking for. This is where he came into. So just delete that and delete that. Okay. So we'll create a code ourselves, and we'll say we just delete this as well. So we'll say def. So we can say upgraded greet function. Upgraded greet function. So we can say def, and we'll say greet upgrade upgrade. Then we'll pass in the name. Then we'll say print or return. Now we use return. But if we don't want to use it, if it's just to display, we can safely use print. We don't want to use that result anywhere, but most times we'll keep on with the with the value or with the return value. So, but in this case, let's just do print. So say print hello name. Then we'll put a full stop. Now, if I click on code, now if we want to run this, we must make sure that there's a default value, because if we execute this, let's execute what is up on top. Then I come down here and we'll say greet upgrade or upgraded. And then we don't pass in anything, it's still not going to work. So how do we make it a default value? We pass in a value in advance into our parameter. That means we give it a default argument. Do not forget that this is a parameter. The value we pass in is an argument. So we'll come back here and say equal. Then we'll give it a name. So we can say user. Okay, you can say user. So just in case they don't provide, it goes with user. So now we call it. So we can just put an hashtag here. Say without argument, and then great upgrade with an argument. So here we're passing the LAN, and then we'll execute this. So it's saying, oh, why? We have not executed this. So rerun this again. So it now knows that there's a default value, and then we'll execute this. So it says, the first time it says hello user, the next time it says hello the LAN. Okay, so the next time it says hello the LAN. Now it understands that, okay, if there is no value supplied by the user, I default to this. I use this. If there is, I use whatever they supply to me. So, and yes, that is how default argument works. So we have now made this argument, this parameter no optional, so that if they don't provide it, we give them our defaults. If they don't like our defaults, they must supply something. So just a quick recap on this. I think here the flow is supposed to be like this. Now, just a quick recap. In this place, we understood that arguments are positional. So let's add a code explicitly. Wrong positioning. So we can say in this case, female is Josephine and is a 45. So let's run this. Female is Josephine years old and is a 45, right? Correct way. Right order. So this one says, we passed it correctly. Josephine is 45 years old and is a female. All right. Now that we have seen position arguments, that means we must know the order in which the variable is or the variables are. But then, what if we've declared the function at in a very big code, and somewhere in the code we just know that it takes these three arguments and we maybe do not necessarily remember the order? What can we do? That is where keyword argument comes in. It says we can explicitly name parameters when calling the function, which allows us to pass them in any order at all. Okay, so in this case, let's create a function called number difference. I think we still have our number difference. Let's test it. Number difference. Okay, so let's pass in 7,9. It seems that okay, it's still working. Now this is giving us what? Not available, or it's giving us a negative value, I mean, because it is doing 9 minus 7. Where did we define the function? Let's quickly check it. Okay, number difference. This is where we define it. So I'll only copy it so that you can see the difference, okay? So that you can see the difference. I'll copy it and put it down here. That's more like we're redefining it. So we're saying return A minus B. Return A minus B. So in this case, it is expecting us to pass in the value of A first before the value of B. Hence, we're getting negative number. So how can we avoid getting negative number? Assuming we do not know the order which it is passed. So we'll say wrong order. We'll run this. It's giving us -2. Now we can correct the order by saying number difference. We can now say B is 7, A is 9. Now this way it forces it to know that, oh, okay, I should not just put 7 into A. I should put 7 into B, then 9 into A. So this now will run correctly. Wrong order. This is now keyword based, not positional. So you can see the difference. So when you don't know the order, you can just pass in the parameter and tell you that, okay, this should actually take this particular value. Okay. So that's the difference between positional arguments and keyword arguments. And yes, pro tip, always put default arguments after non-default arguments in your function. Okay. Because Python might raise what? A syntax error to that. So you might want to keep that in mind. So collapse this as well. The next thing is now to look at multiple arguments. For example, we don't know the number of arguments a user will pass in. However, we still want to be able to handle their request properly, right? Because we're building whatever we're building for them. We don't decide how they use it, except in cases or except in ethical cases or ethical reasons, right? That's the only place we can say, oh, don't do it this way. But then a user can use what is developed for them to be used the way they feel it should be used, right? Okay. So with that in mind, we might want to keep in mind as well while developing, there are different use cases or scenarios that can come or happen while users are using our applications, right? So in this case, we don't know how many positional arguments a function will receive. We can use asterisk arguments. Asterisk in this case is a wildcard, right? We've seen it in SQL, it's in Excel as well, and it is a wildcard. So it collects all extra positional arguments in the tuple, and then the calculation goes on. So let's see how that works, and I will leave you to use the keyword version of it. Okay, if I do the one without keyword, it's just the same idea as keyword and positional arguments. Okay, I have something already. Let's do as. Okay, so let's say we want to get the sum of all the values. I'll just go over this so that I won't type again since it's already there. I don't have it there. So we have calculate sum. Okay, and of course we have seen how for loops work. Okay, we have seen how for loop work. I'm saying calculate the sum of all the numbers the user will put in. We don't know how many numbers the users will put in. So we were saying take all the numbers, and the total by default should first be 0. Okay, total should be 0, and then for individual number in the list of numbers, of course in the tuple that they provide to us, append every number Now, when it loops over it for the first time, so let's assume we have a list of number, or a tuple of number. Let's say we have 2, 3, 4. This is what the user provided. You already know how for loop works. When it executes the first time, it finds 2. And you know this assignment operator already, plus equal. So it picks this number. Total is currently 0. So the first time it runs, it finds 2, adds it to 0. So total is now 2. It goes back to the loop again until this loop is completed. That is when the total, that's when it will return the entire number. Okay, so the loop needs to complete first before control is passed on. So it goes back again, it finds 3, then it appends it or adds it to what is currently in total. That's where the plus equal to shines. So it adds it to the 2 that is there before, it becomes 5. It loops over again and it adds it to become 9. Okay, so if we pass in this value, we will be getting 9 in return. We'll be getting 9 in return. So that is how this works. We'll do our version as well. Probably ours will be multiplication, and then we'll test it out. So let's add a code and say calculate sum. So we can pass in 2, 3, 4, and 1. If I execute that, it's going to throw an error. Yes, because we have not executed this. So let's execute this. Done. Then we'll do this. I'll run it and say 10. 2 plus 3 is 5. Plus 4, 9. Plus 1, 10. And it works just fine. So let's create our own. Dev number products. Number products. We're saying argument of numbers. So in this case, we're saying product is equals to 0. Product is equals to 0. And we're saying for every number in numbers, plural, right? What do we want to do? We want to get product multiply equal to number. And then finally, we want to return products to the users. Okay, so this is what we have. And I can just take everything out so that it looks shorter. I think it's better this way. We'll add this and then we'll run number products or product number. Let's execute this first so that it knows that this function is available for us. Control. Now it knows that it's available. So I want to do, for example, 2 times 3 times 4 times 5. What would that give us? I don't know. Now we're getting 0. What is going on? Why are we getting 0? Do not forget that the initial value is 0. But this is a multiplication operation. So the best thing to instantiate this with is what? 1 in this case. Because anything multiplied by 1 the first time is that number. So we'll run this again. Okay, now it understands, and then we'll run this again. And now we're getting an actual value. So you can think of this as, oh, maybe you can create a function that can add up the first 50 numbers, the first 30 numbers, first 20 numbers. You know, the limit or the option is gradually becoming more. I don't want to use the word endless, but we're getting more options to do more with Python, with the functions we are learning. Okay, we can have loops. By the way, we can have loops inside a function. We can have conditional statements inside a function. We can have variables inside a function, just as we have seen. We can have lists inside a function. We can have everything we've learned so far inside a function. But do not forget that by best practice is good to keep the work of a function or the responsibility of a function on a single thing. Okay, so this is how to use what? The multiple or unlimited keyword argument. Okay, this is how to use the unlimited keyword argument, or just argument, I mean, or multiple arguments. Okay, this should not be here. Okay, yep, it's this way. And we can add a text at the top. Control enter, enter. Okay, so this is the way it is. Now feel free to explore the keyword argument, because similarly, okay, similarly it is the same as argument, but keyword argument collects all extra keywords argument into a dictionary. We've not explored dictionary. Okay, we haven't explored dictionary, but we'll explore it much later. So pause the video for a while and take a minute to scan this code, see if you can understand what is going on here and what do you think this particular function will print before we walk through it together and execute the function. Just pause it now if you really want to give it a shot. Just think about it for a while. All right, or you can just let me explain it to you. We will not be going deeply into it because we have not covered dictionary, because there are some things you might see. For example, dot items is a dictionary thing. So for keyword arguments, in this case, we're saying display info and we're meant to get all details. What's the difference between just arguments, that means all arguments, and keyword, all keyword arguments? We use two asterisks. Okay, so in this case we want two asterisks, that's because the argument will be keyword based. So it says display information as keyword argument. So for key and value in details dot items, now because they will use keywords, it becomes a dictionary. Okay, so we want to unpack the dictionary, we want to loop over the dictionary and unpack it. Think of this like enumerate that we did earlier when we were using for loop, right? So when we're looping over it, we want to take the key and convert it to a title case, then print the value, right? So we're passing the name, the age, and the city. So if I run this, you can see the key itself, right? The key itself, we're grabbing it. If there's an underscore in the key, we want it to be a space, right? And then we're saying it should be a title case. So that means the first letter should be capitalized, name. So let's say, for example, this is full name, because by default we cannot have space, right? So since we can't have space, let's say we use a full name, and I run this again, you can see it's replacing the underscore with a full name. So if they pass in a variable with an underscore, it should replace it with what? With a space. If it is my city, my underscore city should be my city. So we're saying we're grabbing the key. It is very simple. Okay, we're grabbing the key, we're replacing any underscore with a space, and then we're converting it to a title case. So that is the key. And for the value, we're just putting the value in front of it. So let's create something simple so that we can do this. So say def display results, and then we'll say details, when I say record, just say record in this case, and then we'll put in a semicolon. Now we're saying for key and value, because we want to get both the key and the value, right? So for key and value in record dot items, because it will be a dictionary. What do we want to do? We want to print our f string. Okay, we can use our variable. Here will be value, here will be key. So say value, so we'll say value. So here we can say our key, which is what we're getting, dot title. So let's say, for example, we're not replacing anything, we just say dot title. So these are string operations that we have learned before. Here it was chained, right? Okay, there's no dots here. There's not supposed to be dots here. So let me scroll up so we can see this properly. Remove this. Okay. So we're saying the key should be capitalized, and then we should see the value just in front of it. That is all. So in this case, we're saying display results and that will be, let's say, name equals Cynthia, no, Cynthia, and score equals so we can say math score is 90, English score is 75, and we'll say that science score is 99. Okay, so let's run that, and okay, and well, we don't have any outputs. What could have been the problem? All right, I think the problem is just simply we used the wrong function name. So we're supposed to have display results. So let's give that something else for us. And you can see it says name is Cynthia Math. Now you can see the underscore the way it is, right? So if we don't want that underscore, that's why we can do what? Replace function where we chain results, and then we say look for any underscore and replace them with space, an actual space. We'll put the space in the code like that, close it, and we'll put full stop. So we chain multiple conditions using the chaining method, using the dots method. So you can see math score. You can take away the name. We don't need the person's name. And take away the person's name, and you can see math score is this, this is this, this is that. And yes, we have seen both the keyword arguments and the non-keyword argument, okay, which is positional arguments. And yeah, I think there's a short note there for, so the keyword argument and just the positional argument are very powerful. You can use them to create flexible function, especially when designing APIs or function that might take optional parameters. They're often used together. And they're often used together. So it's important that you can combine. That means you can combine a keyword argument and a non-keyword argument. Okay, keep that in mind. And yes, we're getting closer to the end of functions. So we'll collapse what we have so far, and we'll move on to lambda function. A lambda function is what we call an anonymous function, a function without a name. Function without a name is what we call a lambda function. Function without a name is what we call a lambda function. And yes, let's jump into it without further ado. So let's read what is a lambda function, also called an anonymous function, a small single expression that we don't need to name. They are defined using the keyword lambda. Yeah, very important. We have the keyword lambda to define them. Oh, I already have all of this in here. Okay, we'll do ours. It's good when I write it again so you see how it works. So let's look at this first. Now, this is simply an addition function that we had earlier. So let me show you what it looks like. You can say def add add function. So, okay, that is the add function that we have. I want to simply recreate this function right here, this particular one, so that you see it in the proper form and then in the lambda form. So a comma b, and we're saying return a plus b. So this function right here is the same as this. So how did it become lambda function? First of all, we use a variable because since it doesn't have a name, there's no way for us to call it. Remember, we call a function. So since there's no way for us to call it, we have to use a variable to hold the operation. So we have add lambda, or we can just say add two numbers. So add two numbers, add two numbers. So we have add two numbers, add two numbers. So here a and b, a plus b. So you can see the same thing. Now the first thing is that we don't use the def keyword, we use the lambda keyword. So def replace lambda. That's the first thing. Then we don't have a name. So since we don't use a name, we just put in our arguments or parameters directly, a comma b, a comma b. Then we'll put in our colon, we put in our colon. In this case as well, we don't use the return keyword. We just put in a plus b, or the operation we want to perform, just like this. So you can see how this have turned into this. And if we run this code now, you can see we're getting lambda addition 3 plus 8, because I had two numbers. We passed into two numbers and we're getting 3 comma 8, just like that. But lambda are way much more powerful than not giving them a name. We can use them for much more powerful things, and that's what we're about to see in the next couple of minutes. So let's delve into it. Now, higher order functions. What are higher order functions in the first place? Now, consider higher order functions as functions that take functions as arguments or return functions. So you can see by default, a simple function takes arguments, but higher order function takes another function as argument or returns another function. And that is why they are so powerful. And lambda functions are often used with higher order functions such as map, filter, and sort. Okay, we can use map, filter, and sort to simulate some things. Now, let me just put this in different cell. So here we instantiate higher order function like, so I can put this on another line. Okay, and I'll add a new code here, paste it, paste it here as well. I'm not sure why I left these numbers here. All right, so for these numbers we have, so this is just a simple list. We'll run it. So it's a simple list, 1 2 3 4 5. Now, how can we use higher order function? We have a filter, right? So we want to get even numbers from this list. But before that, we are doing another thing in here. We are getting, now if you, let's isolate it simply so that you can see what exactly is going on in here. Now look at this function. What will it do? This is x. It takes a single argument. An anonymous function takes a single argument and divides that argument by 2 and checks if the result is 0. Okay, so in this case, filter is, of course, we're converting the results, the entire result, back to a list. Filter is an higher order function, and you can see it can take key arguments, like arbitrary arguments, a lot of arguments, and can also take keyword arguments. So it says filter, function or none. So very important. This is what you should understand. It takes a function first, then it takes something it can loop over. Iteratable. It takes something it can what? It can loop over. So let's see how it works. So here we passed in a function that is meant to check for even numbers, and we pass in the list of numbers it should loop over just right there. It's as simple as that. So I'll take this out, and then we're saying even numbers, of course, filter with Lambda, and then it prints what the even numbers out. So it is only extracting any condition that it meets. It brings them into this place. I know I'm speaking too many English, but let me run it for you to see it, and then we do our version of it. And you can see what it's doing is just getting us a it's just getting us what's the word now? It's getting us the even numbers only, right? You can see. So let's do something similar. What if before we uh, do this, right? We want to, so we can say, let's get odd numbers in our case. So odd numbers equals to list. We're just converting the answer back to a list. Okay. A filter, and inside the filter, we want to perform a lambda that takes a single value. And what does it do? Checks if the remainder of the value is not equal to 0. Okay. So that is the condition, and we are passing the number list that we have, the same number list. Or we can pass in a range of, let's say, a list, a range of 1 to 10. You can just put 11 there. Okay, so say print odd numbers. So to spice things up, we can say odd numbers between 1 and 10 are, so this is what we have. It looks like a lot, but we're getting there. We're getting the hang of it. We have a number list. This will give us a number list, right? We're typecasting it. Now, this should give us 0 to 10. And we're checking for individual numbers. So let's just start at 1. Since we said between 1 and 10. 1, comma. We're checking if the division of that number has a remainder. That means the remainder is not 0. Then it filters it and drops all of those values in here. So let's just check what we get in return. And you can see odd numbers between 1 and 10 are 1, 3, 5, 7, 9. Just like that. That's how powerful higher order functions are. And Lambda function helps us do a good job here, because it will be hard, or it will not make sense to pass in a full function inside here. We can't pass in a full function inside here, except we have saved it in a variable and we're using that variable in here. So Lambda function helps us do that job in a single go. Okay. Now, how can we use Lambda function with map? We want to square numbers in a list. What do? We use the map function. Map says check, we're not filtering, right? Check individual number and multiply them. So that is what map does for us. So in this case, you're familiar with this. You can see you're now getting more comfortable with the examples as more examples appear. So we have the lambda, takes one argument and multiplies it, or raises it to the power of 2, and it loops over all of this number. Do not forget again that map itself, see, function and iteratable, something it can loop over. So if I run this now, it returns the square of the numbers. And of course, we can use it to sort a list. Okay, this is a list. with different names of people, right? And we have the sorted one, sorted version of it. So it's a list of dictionary. Let's print it out so that we can see what it looks like first. So we get comfortable with it. Students. So, okay, yeah, that's the only thing to print. So you can see it is a list of dictionary. A list of dictionary. So we have a dictionary, we have another dictionary, we have another dictionary. So it's a list of dictionary. Now, what are we trying to do? If you look at it, we passed in student variable. And let's look at how this works. We click on sorted itself. So it says an iteratable first. You can see that is a bit different from the other ones. An iteratable first. Then we have a forward slash, an asterisk, a key, and a reverse. So for the key, now the key is a lambda function. Why? Because we want to sort by grade. We want to sort it by grade. Now it's easier explaining it because you're already seeing it on the screen and you're able to follow. Okay. But the best way to do it for you will be to now write it out, write the code out, and run it. It's important that you don't just like maybe grab the notebook somewhere, just type it out, take your time to type it out and run it. And while you're typing, you're reading it in your mind. You are reading the execution. Okay, this is doing this is doing this. Because your ability to be able to read the code and understand it is very important. Okay. And do not forget, we're sorting, it says reverse, right? Reversing, it says true. So the key will be a lambda that takes a student, it loops over this, so picks the individual student, and we are grabbing the grade of the student only. This is how we access values in a list or in a dictionary. Why? Because dictionary is a key value pair. Dictionary is a key value pair. We'll see that later properly. We don't use index. We don't use 0, 1, 2, 3, 4. All of those things. We don't use that in a dictionary. So we use the grade to grab the value, then we reverse it. So if we print, let's print sorted, or let's just put sorted student here. Sorted students. Then we'll run it again. We'll comment this out instead. So run this again. So you can see now we have Bob first, 92, followed by 85, which is what? Alice, followed by 78, which is Charlie. And yes, we have been able to achieve so much, so much. At this point, or just few minutes before this point, it's possible your brain is telling you, no, you can't do this again. And yes, that happens. So all you have to do is just take a break and come back to it. Okay, take a break and come back to it. And if you still don't understand what happened here, okay, just take a break and then review it again from the IR or from the lambda function itself. It's very important that you have a good grasp of it as we proceed and progress in this journey. Okay. Finally, under functions, we want to see and learn the different scope of variables. Majorly, we want to look at scope of variables. By the way, don't worry, we will not be writing any code. I already have some codes in there for you to no, I'll just explain through them. Okay, they're easy to follow. Now the first one is local scope. Variables defined inside a function are local to that function and cannot be accessed from outside. They can be accessed from outside. So this value 10, okay, this value 10 cannot work outside this function. So let's run this. Now, let's say I want to say total is equal to local var plus 5. And I want to print total. You can see that it's already telling me, oh, I don't understand what you're doing. Oops. And what is it saying? It says local variable is not defined. That means this guy only exists inside here, not outside. I can't call it, I can't print it. Okay, fine. Maybe I don't want to perform any function. I just want to print it outside. Print local variable. It's still telling me it does not exist. Why? It is a local scope. It only exists within this block of code. Within this block of code. Anything outside is you cannot access it. It's as simple as that. However, if this were to be defined outside, right, and we run this, it can work inside the function and outside the function. But the point here is to understand the locality of some variables. So this cannot work outside our function. Of course, because we have declared it outside once, it has executed. So local loc var. I think local variable is the best name, except I'll write it in full. So let me just write it in full so that it gets back. Except I restart the runtime, which is also a good idea. Let me restart the session so it destroys all the variable we have before. Yes. So just wait for that. Restarting. Now it has restarted completely. So if I run this again, now it will run into an error. Oops, I don't local variable. It's as simple as that. Let's move on. Global variable. Global variable are defined outside a function or a class and can be accessed anywhere in the program. You can see in this case we defined it outside. We can use it inside the function. We can use it outside the function. Print global var. So inside the function, accessing global var 20, outside the function, accessing it as well. Okay, so it's as simple as that. Global scope. Now the global keyword, if we want to modify a global variable from within a function, we need to explicitly declare it using the global keyword. Otherwise, Python will create a new local variable with the same name. Okay, so let's take a look at this code. We have 100 as a global variable, standard global variable, right? And then we have a function to modify the variable. So we're saying global x. That means declare that we intend to modify the global variable x. So x is equals to 200. Inside, I think I would have best leave this. I'll just leave this out. However, I'll just stare at the screen. I've started it. Let me just explain it. So for beginners, don't worry. I'll leave this out for now. Okay, I'll leave them out for now. So maybe at some point later, when we actually want to use them, we might come back to them. However, for the benefit of that, I'll leave it on the screen for a while. Just make sure everything appears. Okay, so I think this is the entire. All right, so this is the entire code. Now take a look at it. Read it. Try to understand what is going to do, what is going to happen. This is for the global variable. I believe you have done that, or you put a pause at that particular point. And then we have non-local function as well, which is this. Okay, non-local function. Just take a look at it, scan it. It's simple, but for now we'll not really be using it. So, but in case you want to have an idea, that is what you got right there. Here, finally, we have a mini challenge for you. So you have to create, you have to define. Let's see if we can add spaces to this. Okay, the spaces are now appearing. What else? Okay. So define a function that says calculate area. It takes a length and a width, or length and breadth. So it takes these two functions and returns the area of a rectangle. Call it with some values and print the results. Modify the function again with a default value of 1. Test it by calling with just one argument and then with 2. Again, create a long function, this is 3, that takes a keyword argument, okay, and print each value in a user-friendly format. Of course, the key and value. Call it with some sample data. For example, event is login, user ID 123, timestamp is this. So you should show the event, the user ID, and the login. Something like this. You can come up with another, come up with an initiative, something you want to do. Finally, create a Lambda function is even that checks if a number is even. Use it with filters to get even numbers from a list. Do not forget that this is meant to check. So it tells you if it is even or not. You are not necessarily meant to print out the even numbers. And yes, this brings us to the end of functions. And finally, we have data structures, which will be in another video. And as usual, till the next time again, until the next video, keep practicing, practicing, and practicing. It is important that you don't miss out on any exercise. Take them seriously, because very soon we'll be doing much more than the simple exercises that we have.